Welcome all to YouTube channel Mechanical Study, where we study different mechanical systems. So as we are discussing the thermodynamics series, and today we will going to start from the point where we have left off in the previous lecture. So we already discussed questions 1 to 25. Now we'll start with question number 26. So first question for today's lecture is, which of the following process is irreversible process? So options are isothermal, adiabatic, throttling, and all of this. So out of all those processes, throttling process is a irreversible process. For any thermodynamic cycle, reversible process are drawn with a continuous line, and irreversible process are generally drawn with a dotted lines. So basically throttling process is a irreversible process. Now what happens in throttling process? So in the throttling process, here the enthalpy of a system remains constant, that is H1 will be equals to H2. Similarly here in throttling process, we generally allow the flow of any fluid through a restricted area so that the pressure will reduces, means that it is also called as a pressure reducing process. So in throttling process, enthalpy of a system remains constant, as well as a pressure will reduce at the end of a throttling process. So it is also called as a isenthalpic process, and in this process heat transfer to surrounding is 0. So here throttling process is an irreversible process. The next is a cylinder contains 5 meter cube of ideal gas at a pressure of 1 bar. So cylinder that contains 5 meter cube of ideal gas, and that is at a 1 bar pressure. This gas is compressed in a reversible isothermal process. So a reversible isothermal process is carried out till its pressure increases to 5 bar. Initial pressure is 1 bar, final pressure is 5 bar. So for a isothermal process, law is PV is equal to constant. So here we have to find out the, so in this case we have to find out work done. So here we have to find out the work done. So formula for the work done, that it is nothing but the PdV. So formula is PdV. So here, as you all know that the for isothermal process, law is PV is equal to constant. So P can be written as C by V. So it can be written as C by V into dV. So if you integrate this with respect to V1 to V2, we will get a final equation, that is C into ln of V2 by V1. So this will be the equation where C is the nothing but PV, and if you apply it for a process, then it will be equals to P1 V1, which is equal to P2 V2. So just we have to put that in an equation. Now in this case volume is constant, so we have to use a formula, that is work is equal to P1 V1 ln of P1 by P2. So as for isothermal process, P1 by, that is P1 V1 is equal to P2 V2, so that the P1 by V2 by V1 will be equals to P1 by P2. So we have to put that in a equation of a work done, and here we will get the final answer, that is work done is equal to 804.7 kilojoule. 804.7 kilojoule. Here this will be the answer, that is 804.7 kilojoule. Then next, that is the 20th question, that is the, if H refers to T heat, T refers to T temperature, then in throttling process, as earlier I have told you that in throttling process enthalpy remains constant, that is H1 is equal to H2. So option B will be the right answer. Which of the following processes are thermodynamically reversible? First throttling, then free expansion, constant volume and constant pressure, and last isothermal and adiabatic. So option D will be the right one, that is throttling, free expansion, constant volume, constant pressure process are the irreversible process, and Isothermal and adiabatic process are reversible process. So isothermal process, that is basically the temperature will be remains constant during the process, and if it is to be reversible, then this process is to be carried out in such a way that, or it is carried out at the infinitely slow speed, so that the temperature will remains constant. And in order to have a reversible adiabatic process, it should be carried out at a very fast rate, so that the heat transfer to surrounding will be 0. So these are the things that we must know. So basically thermodynamic reversible processes are isothermal and adiabatic. Next question: the most efficient method of compressing air is to compress it adiabatically, isentropically, isothermally, isochorically. Now the device that is used to compress the air is a compressor. There are basically different types of compressor. That is a reciprocating compressor. Then apart from that, there are different types of a compressor that is basically used to compress the air. So the process that is which is most efficient, so out of this isothermal process is more efficient. Why it is more efficient? So here we can see on a screen, that is, here we can see a PV diagram, pressure versus volume diagram, and on pressure versus volume diagram you can see a 3 curves. This is curve 2 to 4, this is 1 to 4, then 1 to 3 and 1 to 2. As you all know that the compressor is a type of open system. It is an open system, and for any open system, its work done will be drawn on the pressure axis, that is on vertical axis. If it is a closed system, then we have to draw it on a horizontal axis, that is on the volume axis. So here it is an open system, so we have to draw area under the curve. Now a compressor is a power consuming device, so work will be required. So here we can see that in isothermal process the work required is minimum, that is area under the curve is minimum. So one can say that the work requirement in isothermal process is minimum, and it is maximum in adiabatic process. So work requirement is maximum in adiabatic process, and it is in between. It is in between for process polytropic process. Now what is polytropic process? It is a type of process where heat transfer to surrounding take place, and where n is ranges from, that is n is ranges from 1 to 1.4, means its value is not 1 and also it is not equals to 1.4. So it is ranges between 1 to 1.4. So in actual practices, a reversible that is isothermal process and adiabatic process are not practically carried out in the compressor. So we will just carried out a polytropic process, that is carried out in the compressor, which is actually that is actual process that is carried out in the compressor. But precaution is taken that the n should be always be nearly equals to 1, means we try to keep values of n, that is if it is a polytropic process, though we try to keep its value nearer to 1, so that it will consume less work. So this is a correct answer will be the isothermal process. So minimum work will be required in isothermal process. That is the reason why it is most efficient method of compressing the air isothermally. Then next question is question number 31. That is the internal energy of an ideal gas is a function of. So internal energy of an ideal gas, it is a function of, yes, absolutely, that is a absolute temperature. So internal energy for any system is nothing but mCV dt, means it is dependent upon the temperature. That is the change in internal energy is nothing but the mCV dt for any system. So basically the internal energy for any ideal gas depends upon the temperature, or it is a function of a temperature, means as temperature changes, internal energy also changes. Then work output from a system is at the expense of internal energy in a non-flow process carried out. Non-flow processes that are generally carried out in a closed system, that is there will be no exchange of flow of a mass to be taken place from the system, but there will be a transfer of energy from system to the surrounding takes place. So here in this question there is a work output from the system. Okay, so for that purpose we need to know the first law of thermodynamics, that is Q minus W is equal to delta U. So here work output from a system is at the expense of internal energy. So delta is internal energy and work output is a W. So here Q will be 0. So for a process that is a adiabatic process, heat transfer is 0. So correct answer will be the option C. So that is, in adiabatic process heat transfer is 0, so that the work done will be equals to change in internal energy. So option C will be the correct one. Absolute zero pressure will be, as early in previous lecture I have told you what is absolute zero temperature and what its value. So absolute zero pressure, the options are when a molecular moment of the system becomes 0, at sea level, at the temperature of minus 273 Kelvin, at the center of earth. Now absolute zero pressure is the pressure where the molecular moment of the system becomes 0. So option A will be the right answer. So here absolute zero pressure is the pressure that is at a temperature of a absolute zero temperature, that is minus 273.15 Kelvin, sorry 0 degree Celsius, minus 273.15 degree Celsius. This is the absolute zero temperature where the molecular moment of any system will be equals to becomes a 0 and pressure becomes absolute 0. So option A will be the right answer for this question. The next question, an ideal gas can be taken from point K to point N in 3 different paths. That is, first path is KLN, the next path is KN, and third path is KMN. So which of the following is a true statement? Now first is same work is done during each process, so it is not true, because work is a path function and as path changes work will also changes, so work done will be also changes. So it is not the same for all the processes. Similarly, the same amount of heat is added to the gas, so again it is a path function, so it depends upon the path. As path changes, so it is also wrong. Then the same change in internal energy during each process. So this is correct answer, that is internal energy, it is a point function. So basically it depends upon the point, not on the path. That means for any process which followed any path, and if its starting point and end points are same, and the processes that follow different paths, but it is change in internal energy, which is a point function, its value remains constant. So same change in internal energy during each process will be right answer. So option C will be the correct one. So which of the next question, that is which of the following is not a property of a system? So basically there are two types of property, intensive and extensive. So temperature is an intensive property, pressure is intensive property, volume is extensive property. So it is not a property of a system. So correct answer will be option D. In reference to thermodynamic equilibrium, if it is required to have, so in order to achieve thermodynamic equilibrium, system should be in mechanical, chemical as well as in thermal equilibrium. If these three conditions are fulfilled, then system is said to be in thermodynamic equilibrium. So option D will be the right answer. Now for mechanical equilibrium, the force equilibrium must be there, that is there must be equilibrium of forces that is to be done, that is the mechanical equilibrium. Then next chemical equilibrium. Chemical equilibrium means what? That is the system is chemically inactive, then chemical equilibrium should be achieved. And thermal equilibrium is that the system having a temperature that is constant. So these are the three equilibriums. Equilibriums, if it is fulfilled, then mechanical, that is mechanical, chemical and thermal equilibrium, then system is said to be in a thermodynamic equilibrium. So option D will be the right answer. Then next, if the value of n is 0 in a equation P raised to n is equal to constant, then process is called. If a value of n is 0, then V raised to n will becomes 1, so it comes out to be pressure is equal to constant. That means it is a constant pressure process. So option B will be the right answer. in a free expansion of a gas between two equilibrium states, work transfer involves. Now, what exactly free expansion? Suppose there are two rooms, and if in a one room there is a gas particles, and here there is a restriction, and in out and in other side there is a evacuator room, that is a perfect vacuum is there. So pre-expansion is nothing but the, if you allow or if you remove this partition over here, there will be a pre-expansion of the these gases will take place. That means during this process there will be no work done by these gases on its surroundings. So here its value comes out to be 0. So C will be the right answer. So work transfer in all will be 0 for pre-expansion process. Internal energy of a substance depends upon, again same question, that is it depends upon the temperature. The next question, that is the temperature at which volume of gas becomes 0 is called. So it is absolute 0 temperature, and its value is minus 273.15 Kelvin. Not Kelvin, it is degree Celsius. So do like and subscribe to channel. Thank you.